Let's talk about how you work with moles if you have a liquid. The only difference really is you're going to make use of the density of that liquid. So let's take a look at this first example. We have 2,360 milliliters of ethanol, and we want to know how many moles do we have. So we're going to use our mole facts and the formula mass and density to determine the moles of ethyl alcohol. So let's start with what we're given, 2,360 milliliters of ethyl alcohol, and we need to convert it to moles. We're going to have to use the density to convert from milliliters to grams. Density is just another conversion factor to us. We could write the density of ethanol as 0.85 grams per milliliter, or we could write it as 1 milliliter is 0.85 grams. Well, how would we have to write it in this problem? We want the conversion that has milliliters on the bottom. So we want 1 milliliter on the bottom and 0.85 grams on the top. That will allow our milliliters to cancel. Now we're in grams, so it's just like the previous problems. We want to use the formula mass to convert from grams to moles. So we have 46.0 grams in 1 mole of alcohol. We want the grams to cancel. So 46.0 grams will go on the bottom and 1 mole on the top. This allows our grams to cancel, and we will now be in moles. So after we do the multiplication and the division, we should get that number in our calculator, but that would be wrong. 2,360 has only 3 sig figs because this trailing zero doesn't count because there's no decimal in the number. So the correct answer is 43.6 moles of ethyl alcohol. Let's look at another example. What if we want to make one of those 2-layer bottles that we had in the classification of matter lab? Well, if we start with 2.57 times 10 to the 24th molecules of toluene, how many milliliters of toluene should we measure out? So it's a similar problem. We're working in the opposite direction. So start with what's given to you, the 2.57 times 10 to the 24th molecules of toluene, and we have to convert that to milliliters. So we're going to have to use our mole facts. First, we're going to have to convert from molecules to moles using Avogadro's number. We want the molecules to cancel, so 6.02 times 10 to the 23rd will go on the bottom, and 1 mole will go on the top. The molecules will then cancel. So then we're in moles, and we're trying to get to milliliters. So next we'll have to use the formula mass to convert from moles to grams, and then the density to convert from grams to milliliters. So we want the moles to cancel. So for our formula mass, 92.0 grams per mole, we want the mole to go on the bottom and the 92.0 grams to go on the top. That way our moles cancel. Now we are only one step away. So we need to use the density of toluene. We can write this density as 0.8669 grams per milliliter, or 1 milliliter is 0.8669 grams. Which way do we need to use it this time? We want the grams to cancel. So that means the grams need to be on the bottom. So this is the conversion we're going to use this time. So 0.8669 grams of toluene on the bottom and a milliliter of toluene on the top. That will get our grams to cancel. Now we can multiply and divide, and we'll get 4.5306 times 10 to the second, which has too many sig figs. The number we started with had 3 sig figs, so our answer has to have 3 sig figs. This would simply be 453 milliliters. All right, time for you to try one. We have a flask of lavender oil. That is 125 milliliters. We're given the density of the lavender oil, and we want to know how many molecules of lavender oil we have. We're also given the formula mass for lavender oil. So pause the video and try this one out.